Welcome. This is a video just for people who, it's an introduction to proofs, and it's for regular people who get nauseous or just really anxious just thinking about proofs and have been struggling. And let's get started. First, let's talk about parts of a proof, and I'm going to be talking about two-column proofs to begin with because those are the ones that you see the most. There's other proofs, there's things called flow proofs and paragraph proofs, but two columns are the ones that look like this. They have the um, basically the vertical line going down the center, and it separates statements and reasons. And everything on the left has, at the top of it, there's a header called statement, and everything on the right has a header that says a reason. Okay? Now, if you've had algebra, you've done lots of statements. So when you go, like, let's say you say 2x equals 4, and the next line says x equals 2, these are the statements. Those are things that would show up over here. You never have had to give your written reason next to it. And you did that mentally. So like when you went from here to here, you divided by 2, and that's just understood. Well, now in geometry, you got to put that reason down. So I think it's a real good way to introduce this by using algebra since you've already done it, and you'll see it in action. It'll make more sense. That's what I think. All right. Now, again, I'm going to erase all this stuff up here. Talk more about the parts of a proof. At the very beginning of a proof, at the very top, you're going to see something that says given, and then there's going to be some information, and it could be even a picture. So I'm going to say given, and then we're just going to use an example. So I'm just going to say blah, blah, blah. Given blah, 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 whatever they give you. And it could be one thing, and it could be 4 things. It could be a bunch of stuff. All right. So given blah, 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 comma, prove, and then just for purposes of this, I'll just say prove X, Y, Z. Okay. So at the end, you have the statement you have to prove. Okay. So let's start out with what would be in this proof. At the very top, the very first statement or statements would be your blah, blah, blah stuff, whatever they gave you. I mean, you just basically repeat it or copy it right down right here. And sometimes if there's been multiple pieces of information given, people write it all on one line. Some people, including me, like to write kind of write one line for each. It doesn't really matter. They're both correct. But for the reason for all of this, this is the great part. You just say given. That's it. It's like given to you as a gift. Something was given to you, and you don't have to justify why you put it there because it's your starting stuff. Okay. Now, another really nice thing to do is just know that the very, very bottom on the left-hand side, you're going to put this. Whatever it is they want you to prove, that's supposed to be your last statement. So whatever it is. If they said, prove triangle ABC is congruent to triangle XYZ, you would write that right there. And you could even put that in now, even though you don't know what the reason is. So it's all this middle stuff. These are the parts where you add in, and this is going to be definitely your add-ons, what you come up with on your own. So add-on statements could be one, it could be more, okay? And each add-on, every single one's going to have a reason next to it. And and let me just erase this. I'm going to give you some examples of reasons, not examples, but the general categories of reasons are theorems, postulates, things that you'll see in the back of your book usually, definitions, and properties. Those are I thought 4 main categories. Properties. Okay. Now what happens in geometry is that we start out usually, obviously with chapter 1, and you get a few theorems and postulates, like usually the angle addition postulate, and some other initial, the angle addition postulate. You can find these usually in the back of your book in an appendix, and they start out and they go in order. And as we go through the year, you get more and more of these added on that you can use in a proof. Okay? But you'll have to justify each line of each statement. But if you can't think of the reason, usually just at least put down your statements. Even if you can't think of the reason, you could possibly put it in your own words to describe what your reasoning is. But you are supposed to use more of an official theorem, postulate, definition, or property. Okay, so, and then your last your last reason also is going to be one of these 4 categories. So let's try some using, what I'd like to do is try something you already know, something you're very comfortable with, and that's algebra. Okay? Now with algebra, we're just going to use some basic equations. So let me start out with one that's 2 steps. So 2x plus 3 equals, let's say 9. Okay? You would normally say on the very next one, you might write minus 3 on both sides to kind of show what you're doing, and then write 2x equals 6. But for purposes of the proof, you're going to eliminate this part of it, this step right here. You're just going to skip right from 2x plus 3 to 2x equals 6. So it would look like this. 2x plus 3 equals 9. Some of you probably already do it this way anyway. 2x equals 6. Usually when you get to advanced algebra, after the year after geometry, you stop, putting this stuff in here. And you can go from one line to the next as long as you're just doing one thing, and it's real obvious and understandable to the person what you did. Okay, and then the next line, you would just say, you're mentally going to be dividing by 2. You would say x equals is 3. Okay, so that's what it's going to look like in the proof on the statement side. Everyone knows, by now, that whatever you do to the left, you have to do to the right. You have to do it to both sides of the equation to keep the equality. So you have learned that you add, subtract, multiply, or divide on both sides to keep the equations equal. And the fact that you can add, subtract, multiply, and divide, those 4 operations, are called properties of equality. You have the addition property of equality, or we have subtraction. I'm just going to call them POE for now, for property of equality. You've got subtraction, I'll just shorten that, POE. We've got multiplication, and of course, let's not forget division. Okay, and those are properties that we're going to use in our beginning proofs. Okay, I'm going to skip that because we just did one like that. So I just talked about these 4 properties of equality. Now I'll talk about these 3 over here. The given I already talked about. You just write down the original information. Simplification. That's when you combine like terms. You're not adding, subtracting, multiplying, dividing. You're just making one side of the equation look different, and you haven't changed the actual value of it. So that's called simplification. And then distributive property is when you have parentheses, and if you have a factor on the outside, like this one, you have to multiply it by every term inside the parentheses. So we're only going to use really these 4 properties of equality, simplification, distributive property, and then the given as our reasons today. And we're going to start doing a proof using algebra. Okay, so just make you more comfortable. And then there'll be a couple more on the next page that you can try on your own. So on the left-hand side, I'm going to write the word statement. I'm always going to write statement on the left, and I'm always going to write reason on the right. Okay. Now, if you want to, you can draw a bunch of lines. I think it's better to just do it as you go. So, of course, the very first thing I'm going to do is I'm going to write 3x minus 9 equals 12, because they gave it to me. So it is my given. I love that one. It's my favorite. Okay. So accomplished. Also, at the very bottom, if you really felt like it, you could just write x equals 7, because that is what you're supposed to prove, and you know that it's going to be your last statement. So if you wanted to, like right now, if I was your teacher, I'd probably give you a good amount of partial points just for getting the structure going. Now to go from here to here is what we have to do on our own. Okay, now don't worry about the fact that it's a proof. Just think about what you would do if you were in an algebra class. We would add 9 to both sides. I'm not going to write plus 9, I'm just going to write 3x, and then equals 12 plus 9 is 21. Okay, and what we did just there is we added to both sides. So that's going to be this one up here, the addition property of equality. And I'll just abbreviate a little bit. Addit, P-O-E. Okay? And to go from, oh my goodness, I don't even need this line here in the middle. I'll just kind of Put a little space in. I tell my kid, if they draw an extra row and they want to just draw a little line through it, that's fine. So to go from the next line, or from 3x minus 21, I'm sorry, 3x equals 21 to x equals 7, we're dividing. Okay, so the very next line is what we're supposed to prove, and I just got to write division, POE. That's it. And you're done. That's all there is to it. Another thing I do want to mention, though, too, is that this is sort of confusing for people. The reason that you put has to go with the justification of how you went from the line that's directly on the left, how you got there from the line above it, okay? So this division POE explains what I did to go from this line above to this line here, okay? So let's try a couple more. Or, well, let's start. I'll do one more, and then you, if you want, on the next page, you can pause the video and then do some yourself. Okay, statement. That's going to be right here. We're going to put this given statement here, 3x. Oops, I've already made a mistake here. Okay, it is 3 times 4x minus 1 equals 9. And then my reasons given. And I know that down here, my last statement's just going to be x equals 1. Okay, so let's just kind of do it like you do it in algebra class. 3 times 4x is 12x. 3 times negative 1 or minus 1 is negative 3. Okay, so we didn't do anything to the right side. We just simplified the left side by using the distributive property. So I'm just going to shorten that and write distrib prop. Okay. All right. Now to go on the next line, I would add 3 to both sides. Okay. Now, by adding 3 to both sides, I use the addition property of equality right up here. This one. It goes with POE. Okay. And actually, I don't need the space here. To go from here, 12x equals 12 to x equals 1. We would divide both sides by 12. Since we're dividing, that's the division POE. Okay. So once you're starting to get a feel for how proofs work. Let's go to the next one. Now this is going to say pause the video right here. As soon as you see the next two problems, as soon as they come up, put it on pause if you're ready to try this yourself, and then then you can skip ahead and see the answers. Okay, so I'll wait for you to pause. Okay, now I'm going to start it. So I'm going to just rewrite all of this here under statement. X divided by 5 plus 4 equals negative 1. Reason given. Nice, I love that. Okay, I would take away 4 from both sides. And that would make this negative 5. And that is because I subtracted 4, that's subtraction POE. PO. Alright, now I would multiply both sides by 5. I'm not going to show that I'm doing it, I'm just mentally going to do it. And now we get x equals negative 25. And look at that. That was what I was supposed to prove. I'm already there. So amazing. Okay, and that is... Oops, go away. Okay, that is multiplication POE. Very nice. Hopefully you were able to do that on your own. Okay, now here's another one. I'm going to write all of this over here. It's kind of long. This is where I make my most mistakes. I think a lot of people do, just writing the equation down correctly. Okay. I would say half the mistakes I make are that. Okay, now here we go. I've got it all written down. The reason was given. What I'm going to do here is combine my like terms. I've got a negative 2x and a positive 6x. Altogether, that's 4x plus 1 equals 9. And because I didn't add or subtract anything to both sides, I just combined like terms. We call that simplify. If you want the list, it's on the prior slides. You can go back in the video. Simplify. All right, now I'm going to take away 1 from both sides. Okay, since take away means subtract, so it's subtraction POE. All right, and to go to the next line, which is x equals 2. Oh my goodness, and that matches what I'm supposed to prove. Oh, I'm almost done. I went from 4x to x by dividing by 4. That is the division POE, because I divided both sides by 4. That's it. I don't think I have any more to do to show you, but let's see. I do. Well, I'll go ahead. You can go ahead and end the video if you'd like. Please feel free to like the video if you liked it. But I'm going to go ahead and write these down and walk through them. This will be another chance for you to try them on your own. So if you want to, just go ahead and pause. So I'm writing everything down here on the statement and the reasons given. And distributive property, we're just going to make that 6x minus 3 times 5 is 15. Okay, and that was the distributive property. In the next line, I would be adding 15. Oh, wait a minute. What did I just do? Oh, I'm going to take away 6x from both sides. That's what I would do. 7x minus 6x is just x. Aha! Okay. And that would be the... what I did was I subtracted 6x from both sides, so it's going to be the subtraction property of equality. Okay, now, here, I would probably stop it here, but it does say x equals negative 15, which is a different statement, so I need to rearrange my sides of my equation, and that's called the reflexive property. I didn't have that on my list, so hopefully you're remembering this. Reflexive property means when you switch, you can switch sides. Okay, another one. This is 2x plus 7 equals 6 times 3x minus 2. I'll squeeze that in. And that's my given. And I'm going to go ahead and use the distributive property on both of these. Okay. I'm distributing the negative sign to both the 2x, which would make it negative 2x, and to the positive 7, which makes it negative 7. So I'm adding negative 7. I simplify that to just minus 7. 6 times 3 makes this 18x. And then 6 times my 2 is 12. Okay, I'll squeeze that in. There's my distributive property. All right, next, I think I would probably add 2x to both sides. Everybody could treat this differently. This is what I would do. And if I added 2x to both sides, this 18x would become 20x. Okay, so I added 2x. That's going to be my addition property of equality. Okay, in the next line, I would add 12 to both sides. That's going to give me 5. And that's another. So since I'm copying the same reason, you can either use an arrow to go down, or a lot of people do this. They just use quote marks to show that they're repeating something from above. Usually one quote per word. I'm just going to say one quote for all of that. And the next line is, I'm dividing both sides by 20. Okay, again, I'm dividing both sides by 20. 5 divided by 20 is 5 over 20, which is 1 over 4. And that is division POE. And again, just like this other one, I'm going to swap the sides of the equations or reverse them. And that's my reflexive property. All right. I am done with the video. Thank you for watching. And if you like the video, please mark like or make a comment if you have any feedback. Thank you very much.